Hello, welcome to ZenView Studios Lab. Eric here. So today is a following video. It's the second video about capacitors. I made a small video about the LCR meter I got recently, but I want to go over capacitors, mainly electrolytic capacitors. There's some other failures. Film capacitors fail also, older ones specifically, but one of the biggest deal is with electrolytics. The reason being that it's not so easy sometimes to say if it's good or bad capacitors when their shape is not good, and we'll see it. I will show you in the zoom. It's easy to see if it's bulging and to determine that there is a problem. But sometimes you have capacitors which have no external signs of problems, and in fact then it's only technical measurement that will tell you whether or not the cap is good or not. And since this is one of the things that you, especially in audio, might change very often, and that will also create problems. I just wanted to make this video. Many have been done, and I will put links as to a lot of material that you can find on the web that explains things about capacitors. However, I never found such a very clarified step-by-step approach, and that's what I will try to give a little bit in this video, specifically about electrolytic capacitor. So let's go about it. So here we go. As I said, the first thing in a capacitor, when you look at it on the board, is the shape, the way it looks. This is a bulgy one. It has some say this is one which has the bulge. The other one doesn't have the bulge. You see, same cap. Both are bad, but one you can see immediately. At least you ought to be able to see. Let's see if I can zoom more. Okay, you see the top part is bulged. And this is typical of capacitors that have failed. You will have also shapes like this. We see lots of little impacts on those. This is failed capacitors. Without even knowing the values or anything, you can tell there was a problem with those caps. Some caps are even worse than this. But sometimes, then, when it's not electrolytics, it might just be cracked on the case or things like this. So the first absolute thing is the way it looks. Always take a very careful close inspection of the caps. That's the first thing. The second thing is the value of the cap, and we'll measure that with any kind of capacitance meter, be it an ESR, a more sophisticated meter, or just a simple multimeter which has capacitance. It will tell you if the value displayed is off by a large amount compared, if the value measured, is off by a large amount compared to the value displayed, it's dead. That's as simple as that. I'll show you examples. This one says 4,700 microfarad, and you will see, I will show you, the measurement is totally off. This is the first absolute sign. There's another sign which is more sophisticated that will tell you it's dead, but the first thing is just compare measurements. 4,700, it should be plus minus 5–10% off, but not by half. This is what you ought to see. That's the simplest thing you have to do. Just the shape and the measurement of capacitance. Those are the first elements. Then come what we call ESR. ESR is a measure of the series equivalent resistance that's in the capacitor. And it gives a very good idea of whether the capacitor is good or bad. Except that ESR is a complicated measure also, because it depends on the frequency. It depends on the size of the capacitor. It depends on the value of the capacitor. Meaning, first you have to have a feeling or a table, to put it in another way, as to what you should expect for an ESR for such a value capacitor. Here it's 100 microfarad, 50 volts. What's a good ESR? What's a bad ESR for it? There are tables. I will give you links to the tables. So this is how you get a first feel. But besides this, there is a simpler way. In fact, when you don't know whether it's good or bad, it's just to look to put a signal generator on the cap. This is one of the methods that's shown on internet, and you can derive from it also an ESR value. But the visual clue that you get on a scope will give you a very good answer already as to whether the capacitor at the voltage you're testing is working or not. Now, even more sophisticated than this, the second level of judgment will be, will it work at the voltage that it's meant to? Because this is when everything comes together. You might have a good ESR, might have a good capacitance value, and still the capacitor might not be good. For that, you'll have to check what's called the dissipation factor. This will give you always a clue, but however, you have to know also what's a dissipation factor, a good dissipation factor relative to your type of capacitor. So all these are judgments that you have to make one after one to be able to assert whether it's a good or a bad cap. And that's the difficulty. And this is why there's so many videos about it, because first there's many ways of doing ESR measurements, be it with a meter like we saw last time, like this meter, but you can do it with, I showed it with a scope, with a multimeter, with a signal generator, many ways. Some are more, some are easier than others. Obviously, LCR bridge is the easiest way to go about it. If you know it's good and okay at giving you values, it will be much quicker to decide with this. However, be aware that always, especially when you're dealing with high voltage capacitor, this is where it's the most problematic, because some of the values might be good and just one value might be off, and this is the indication that the capacitor in fact has failed, particularly in high voltage situation. Okay. So let's see just a practical example here with this one. Okay, it's in resistance mode, sorry about that. Let's put it in capacitance mode. Here we can see the capacitor value reads out 365. It's a 390 microfarad capacitor. You can see if you see it. It's a 390 microfarad capacitor. It's good in terms of capacitance. The ESR that I read is 0.1, so 125 milliohms, so it's 0.1 ohm. That's also very good. Now the dissipation factor of the capacitor is 0.2850. This is where it might be a problem. In fact, there is a problem. But we forgot one thing, bulgy. It's bulgy, so it means that it was submitted to higher temperature, pressure, and leakage, or attempt of leaking. So this is dead. No matter what I read here, this is bad capacitor. This is how you have to judge. So you see, no need for measurement. Just looking, the first rule was you throw it away. Okay. Another one. In this case, it reads 2580 microfarad. What does it say on the capacitor? 4700. That's the second rule. Value value, not coherent, bad. It's finished, okay? It's dead. Sometimes you can recover capacitors, that's something else. I won't go over it so much in this video, but here the value is totally off. The capacitor is dead. There's another very good clue here. I don't know if you can see it. I will try to zoom to show you. Okay, let's try again. Remember when I told you about, okay, let's see, sorry if you can see this. I told you about dissipation factor. Well, here we can see the dissipation factor. It's 1.14. That's enormous. That's bad. This means no matter even if the capacitance was okay, with such a dissipation factor, this is bad. And you see the cap is still looking fine, there's no problem. But there were two clues, two signs. Values was off, but this could actually not be the case. Sometimes you'll have a value which is okay. Just like here, the value was okay. But here, not only the value is bad, but the dissipation factor is off, totally off. Okay, you see it, 1.13. So this is bad also. So those two caps were taken off because no matter how they looked, obviously we had, this is even worse, 1.25. We had clues that they were failing. I mean, this was in a power supply, and the voltage regulator wasn't doing and the ripple was, nothing was working the way it should have. These were the caps which were bad.